Hello everyone, this is chapter 2 on the human body. Here's an overview. Regarding the chapter, please read the following sections. You don't have to read the entire chapter, but do read the introduction, the digestive system, the urinary system, the immune system, and the indicators of health. So the overview on this page is showing the 3 systems plus the body mass index, body fat distribution, and then we have a summary in the end. So with the digestive system has 3 main activities: digestion, absorption, and excretion. So what I'd like you to do is please get out a piece of paper and you're going to draw along with this video. So I'm going to enlarge it for the whole screen because I really want you to dial in what you're going to see, and it's even color coded. It's a very cool video. So let me pull it up here. Here we go. So I hope you're ready.
One of the keys to understanding child nutrition is understanding what happens to the food our children eat once it's entered their mouths. So let's start by drawing a very basic model of digestion. Now, the food our children eat can be broken down into 3 categories, and they're categories of what we call macronutrients. And all of these macronutrients are digested in slightly different ways. So I'm going to color code them so that we can sort of follow what happens to each of these categories of macronutrients. So the major macronutrients are carbohydrates, I'll write carbs for short, fats, and proteins. When we use the term micronutrients, we're talking about things like vitamins and minerals and the other important components in the food that we eat. Now, the digestive tract is actually just a long tube that extends from the mouth all the way down to the anus. So we're going to follow that tube and trace the path of food after it enters the mouth and as it passes down this long tube that leads all the way through the digestive system. Digestion actually begins in the mouth with the act of chewing. That's an important part of digestion that we sometimes overlook because it makes big pieces of food. It breaks them down into smaller, more manageable pieces that can be attacked by the different enzymes. And some of those actually are secreted directly into the oral cavity or the mouth by accessory glands called salivary glands. And the salivary glands secrete saliva, surprisingly. And in that saliva are a couple of different enzymes, and I'm going to color code the enzymes as well. So the first enzyme that's in the saliva is called amylase, and amylase works to begin the digestion of carbohydrates. That's why I've done it in purple. We call that salivary amylase because there's also another kind of amylase that comes into play later on in the digestive tract. The other enzyme found in saliva is called lipase. And we also call that salivary lipase because there's a different kind of lipase that comes into the picture later on. And lipase begins the digestion of fats. That's why I've drawn it in yellow. So food is chewed in the mouth and then swallowed down in the form of what we call a bolus. And it's sort of, that bolus has been mixed up with the salivary juices or the salivary enzymes. And it passes down a tube called the esophagus. This is the esophagus. And the esophagus leads down into a dilated part of this tube that we call the stomach. So this is the stomach. And there's actually a sphincter here, or it's kind of like a valve that we call the lower esophageal sphincter that guards the entryway to the stomach. And if that valve becomes leaky, then food can actually leak up from the stomach and give us heartburn. That's where heartburn happens. So once food enters the stomach, it gets mixed with a bunch of other things that are secreted by the stomach. Things like hydrochloric acid or stomach acid, and I'll just write HCl because that's the chemical abbreviation for hydrochloric acid. The stomach also secretes a digestive chemical called pepsin, and pepsin, I'll draw it in green because pepsin, you guessed it, it digests proteins. And the other thing that the stomach secretes is a chemical called lipase. And this is gastric lipase. Gastric means it comes from the stomach. And just like the salivary lipase, the gastric lipase continues the work of digesting the fats that have entered the stomach. Now, the stomach is really muscular, so it kind of churns all this food around, the food that's come down the esophagus as a bolus. And what ends up leaving the stomach is more of a liquid, and we call that liquid chyme. That's what leaves the stomach. And it leaves the stomach through another valve or sphincter. That's the pyloric sphincter. That's a good word for a spelling bee. Okay, so once the chyme has passed through the pyloric sphincter, it enters into the first part of the small intestine, and that part of the small intestine is called the duodenum. I'll just write that in, duodenum. And some really important things happen in the duodenum, or the duodenum as it's sometimes called. And what happens there is that the liver secretes a chemical called bile. And that bile is stored sometimes when it's not needed immediately. It's stored, so it's created in the liver, and I'll just draw it kind of coming out of the liver. And then it actually is stored in a small organ called the gallbladder. That's over here. So the gallbladder is going to store the bile. And I'm just going to get that in for you. That's our gallbladder. And this is our liver. And then when the bile is needed, and I'll just write the bile in here in yellow, so you can probably guess what the bile is used to digest. When the bile is needed, it's secreted out of the gallbladder and it enters the duodenum right about here. And there's another accessory organ that also sort of dumps its products into the duodenum right about there at the same spot. And I'll draw that one in blue. And this accessory organ is called the pancreas. The pancreas. And the pancreas is really important. It secretes probably the most important digestive enzymes into the small intestine. And those enzymes are amylase, and this is now pancreatic amylase. It also secretes pancreatic lipase, another way of digesting fat. And then it secretes two enzymes that are used in the digestion of protein. One is called trypsin, and its cousin, chymotrypsin. So all of that exciting stuff happens in the duodenum. And after that, the small intestine continues. And it continues on for anywhere from about 15 to 30 feet. So it's really long and coiled up on itself. I'm drawing it kind of spread out. These coils of small intestine are actually all curled up on top of each other. The second part of the small intestine, and I'll just try and give you a sense of how long this part of the tube is. And the second part of the small intestine is called the jejunum. Jejunum. And then the last part of the small intestine is called the ileum. And basically, the small intestine is where big particles of food are broken down into their absorbable units and absorbed in this tube, the small intestine. What happens next is that the small intestine joins the large intestine. And the large intestine is sort of like a storage and drying unit, if you will. And it kind of curls around, and there's an ascending portion, a transverse portion, and the one I'm drawing now, the descending portion of the large intestine. And it ends in an S-shape part that we call the sigmoid colon. So this would be your ascending portion of the large intestine, the transverse, and the descending here. I'll just write DES for lack of space. Now, what's absorbed in the large intestine are things like excess water, so the longer feces, because this is ultimately going to be feces that's secreted out once it passes through the sigmoid colon. This is our end product of digestion, and feces is going to pass out through the anus. So the longer the feces sits in the large intestine, the drier it's going to get, because water is being absorbed and some solutes are also being absorbed in that tube. So the food we eat is going to be chewed up in the mouth and swallowed in the form of a bolus. The bolus is going to pass down the esophagus and through the lower esophageal sphincter into the stomach, where it's going to be mixed with stomach acid and things like pepsin and lipase and turned into chyme. That chyme is going to pass through the pyloric sphincter, and it's going to head down into the duodenum. And in the duodenum, bile from the liver and the gallbladder is going to be secreted into this part, as well as the pancreatic digestive enzymes like amylase, lipase, trypsin, and chymotrypsin. So while this food is digesting into its smaller absorbable parts, it's also being absorbed as it passes through this long tube. And you can see how much time there is here to absorb all of the nutrients, because we don't want food to pass through here without enough time for those important nutrients to be absorbed. And then it gets here to the large intestine, and this valve, I didn't put this in, but this is called the ileocecal valve, because it's between the ileum and the cecum. And interestingly, in case you're interested here, this is where the appendix is. It's a little kind of pocket extension of the cecum. And if, for example, you eat a grape.
Okay, time out. What she's going to say now is not proven, so disregard it. This is a fantastic video, beautifully done. I can't say enough about it, but this is not true.
And you swallow all of the seeds and you have pretty bad luck, then one of those seeds might get stuck in here, and this appendix might get clogged and fill up with pus, and then you've got yourself an appendicitis. But
okay, I'm going to tell you what they think about appendicitis. They don't understand it, first off. Western medicine does not understand the GI tract that well at all. It's kind of a mystery, honestly. The theory goes that what is in the appendix is like super bacteria. So we have friendly bacteria on our skin, we have friendly bacteria in our gut that keep us healthy, actually. And the thought is that in the appendix, there are like super bacteria, like Wonder Woman and Batman and all the good guys in there. And that when there is a storm raging outside in the intestines, they go out and clean up the job. They're kind of like the fireman or firewoman, fire person of the GI tract. And the thought is, because appendicitis isn't that common, the thought is that when they go out and have a battle and they come back, sometimes they might bring back with them some bacteria on the bottom of their shoes, if you will. And they bring it back into the house of the appendix, and then there's a fight there. And when someone has it growing with pus and has to have appendicitis, has appendicitis, has to have an operation, then they most likely, the bad guys won. Okay? So I hope that helps.
If you're lucky and that doesn't happen, then the food that couldn't be either digested or absorbed passes into this ascending colon and slowly moves up through the transverse colon and down the descending colon as it's kind of progressively dried and stored. And then once it enters the sigmoid colon, then a bowel movement is triggered and feces are secreted through the anus. And that is sort of the big picture of how digestion works. Now, I just want you to have kind of a window into what it looks like if we took, let's say, a cross section through this small intestine. Let's say I took a slice like this out of the small intestine. What you would see would be a muscular tube like this. Let's say this is the chunk we've just cut out. And that tube on the inside is going to have these kind of finger-like projections. And these finger-like projections are called villi. So this is a villus, but I'll write the plural term, which is villi. And I'll just make this arrow point to two of them so you understand that that's the plural term. And the villi, what they do is they increase the surface area for absorption of all of those important nutrients that are going to be found in the lumen. So the proteins, the fats, and the carbohydrates that are going to be passing through this lumen. And better yet, to further increase the surface area, there are these kind of small, they look like hair-like projections projecting off of the villi. And this is what we call the brush border. These are called microvilli, or smaller villi. And the microvilli make up the brush border. And what that does is it further increases the surface area for absorption in the small intestine. Now, just to give you another view of what the small intestine looks like, what happens if I were to give you another cross-section that looks like this through the wall of the small intestine? What if we were to kind of slice it open? What you would see, you have your muscular wall here, and here are your finger-like projections called villi. Because we've zoomed in a bit, you can actually see that the brush border or the microvilli are actually made up of cells called enterocytes. And each of these cells has their own nucleus, and they're actually selective cells that can aid in the absorption of all of the important nutrients in the small intestine. So these guys are called enterocytes. Now, inside each of these villi, these finger-like projections, is something called a central lacteal. And the central lacteal is actually sort of a projection of the lymphatic system. So the central lacteals are continuous with the lymphatic system. And because I'm drawing them in yellow, you might guess that the fats that are going to be in this lumen, and they've been emulsified by the bile, they've been broken down into smaller pieces by the gastric lipase and the salivary lipase and the pancreatic lipase. All of these small units of fat are going to be absorbed into the central lacteal and pass into the lymphatic system. Now, there's also in each of these villi, there is a little capillary network. So each of these villi, each of these central lacteals is surrounded by a network of capillaries that bring blood toward the villus and then also take blood away. As capillary networks do, they carry blood away from an area. So the proteins and carbohydrates, these are our carbohydrates, and these are our proteins. And these guys are going to be absorbed directly into the bloodstream, into the capillary networks that sort of surround these central lacteals. There are our carbohydrates going in. So you can see that this is how the small broken down particles of the food that we eat actually get into our bodies, get into our bloodstream. And next, we're going to be looking at how our body uses those building blocks for either energy for growth or for storage in the human body.
Okay, so we'll stop here and we'll start a new video.